talk, we will use high-resolution biostratigraphy and maximum flooding surfaces to correlate the South Marsh Island 222 and 223, the 230 Davy Jones, 1 and 2 actually, and the shallow shelf with the ultra-deep shell Baja Alamitos Canyon 557 to the Balm 101 in Campeche Bay. Age-dated maximum flooding surfaces were identified in each of the wells and were used to assist in correlations. A series of donated intersecting 3D Fairfield nodal seismic lines were also used to assist in the correlations. So we'll start out with a little introduction, and we'll talk about the methodology of maximum flooding surfaces identification, and then we'll go to South Marsh Island and talk about Davy Jones, and then Shell, Alamitos Canyon, the Balm, and then we'll have some conclusions. So the first area we're going to look at here, the first area we're going to look at is up here in the South Marsh Island area. The methodology that we're going to do is the high-resolution biostratigraphy was completed on wells using calcareous nanofossils and planktonic forams and doing the paleo water depth interpretation. So the occurrences and the abundances of each species were recorded on a checklist and a biostratigraphic table. Species abundances were plotted as histograms to help identify the maximum flooding surfaces. Maximum flooding surfaces were identified from ages, marker species, high gamma, low resistivity on logs, high fossil abundance peaks, correlated with continuous reflectors on the Fairfield nodal 3D seismic lines. The age-dated maximum flooding surfaces were annotated at the well trace on intersecting seismic lines. The methodology that we use is first we make a table after we identify the marker species, and then we make the abundances. These are in red are the nanofossils, and blue are the forams. And we take and find a marker species associated with these high abundancy peaks, and then we go over to the log, we look for the high gamma, low resistivity, and then we go over and look for a through-going reflector on the seismic. This is a checklist that we use, and we have, these are the fossils we identified. These are all the marker species we picked out, the age over here, and the first occurrence downhole of the fossils. And then the wider the bars are, the more abundant the fossils are. Then we make a table, and we again put the depth and all of the information. Again, the red are the nanos, blue are the forams, and then we come over here. So we caught this as be middle Miocene, I guess lower Miocene, and so and then here's the water depth. So we make a chart like that for each well. And then we convert the checklist that we had, we convert those occurrences and abundances of the fossils, and we make the abundance and diversity fossil histograms. So these are the histograms we make from the charts. They're very, very valuable. So here's a maximum flooding surface up here that we're going to recognize. This is the maximum flooding surface condensed section. So as you come down the well, you hit another maximum flooding surface and another maximum flooding surface condensed section. Now Galloway would call this from here, from this maximum flooding surface to this maximum flooding surface. Galloway would call that a third order genetic sequence. Vail would call this is the sequence boundary, and that's a sequence boundary, and Vail would call that a third order depositional sequence boundary. This is very important, so I'm going to read this. This is a condensed section, and this is what my whole talk is about almost. The condensed section is a thin chronostratigraphic interval of hemipelagic and pelagic marine sediments deposited at extremely slow rates during sediment starvation on the inner outer shelf slope and abyssal plains through a period of maximum relative rise of sea level and transgression of the shoreline. It is characterized by orthogenic minerals and maximum abundance and diversity peaks of planktonic fossils. The maximum flooding surface within the maximum flooding surface condensed section provides a chronostratigraphic time correlation between the shelf and slope sediments. And with that, we'll take that after we've identified these maximum flooding surfaces, we place that on that biostratigraphic table that I showed you before, and we date those maximum flooding surfaces, and we also have the same chart that we showed before. And this is the cycle chart that we use. So we have these are the shaded areas on this chart, the Miocene, are the condensed sections. So they're thickness of rocks. The maximum flooding surface is the peak of this triangle, and if you back that up, that's the age of that maximum flooding surface. And the bigger, the larger the triangles, the more important the maximum flooding surfaces are. Okay, so now then what we do is we go in and we look at and we have our maximum flooding surface identified, and now we correlate that with the well. So the well trace, we take the well trace in here, and then we can move the maximum flooding surfaces in seismic time. We move those onto the seismic so that you can have a correlation from the logs and to the seismic. So we'll start out here at this is the area of the South Marsh Island, and this is the first well we're going to look at is a 222, and then we'll correlate that over here to 223. I'm not going to use very many well names, so in the 222. We identified six maximum flooding surfaces. I'm sorry, okay. So we have 6 maximum flooding surfaces that we have identified, and of course we dated the rock, dated the maximum flooding surfaces. And then we correlate that over here. Here's the 1420. Here's the 1420 over here, and that's down here. And this is the 720, so that should be up here someplace. So we correlate from the table onto the log. And now we look at the 223, and 8 maximum flooding surfaces were identified in the 223, and this is one I just showed you, but it's the same thing. So we identified the 8 of the maximum flooding surfaces, and then that goes all the way down. Here's 1420. This goes all the way down to the 2290, and that should be right about there. You notice that we've gone through a nice salt well here. So that's a deep well. That's an old El Paso well. And the maximum flooding surfaces in the middle upper Miocene in the 222, the first well I showed you, are correlated now to the, in order to move on down with ages. So we've identified here the 222, 223, and now all these nice maximum flooding surfaces are moving across. These upper ones, the upper ones in the 222 were correlated to the 223, and then we'll move down to the next. So now we're going to move down here to the Davy Jones. Here's the Davy Jones number 1 and the number 2, block 230 and 234. So the seismic correlation of these two, seismic well logs and biostratigraphic correlation of the wells in the South Marsh Island 222 and 223 were used now to correlate to the Macarand Davy Jones number 1 in block 230. And good old Davy Jones here, he's, I guess he was an old captain of a ship. And they named it that, but this is kind of interesting. Back in February 2010, the oil and gas investor said that the Davy Jones is a treasure. Macarand exploration has detected buried treasure at its deep Davy Jones prospect on the Gulf of Mexico shelf. The prospect covers 20,000 acres and is a monster of the deep. Potentially one of the largest discoveries in decades on the Gulf of Mexico shelf. And the Davy Jones was placed at the well location and line A of the nodal seismic from Fairfield and projected down to 30,000 feet. So the Davy Jones, we identified nine maximum flooding surfaces in the middle, upper, and lower Miocene in the 223, and were correlated with the maximum flooding surfaces in the Davy Jones 230. So we've gone from the 223 now to the 230, and that's this correlation. So here's the 223, goes all the way down to 22 maximum flooding surface 2290, and that's about it. Doesn't go any further deeper. But the Davy Jones, we projected this well all the way down to 30,000 feet, right down here. Subsequently, Dr. Peter Vail and myself interpreted the stratigraphy below the Miocene that we were able to correlate. We recognize sediments as Oligocene, Eocene, Paleocene, based on seismic and sequence stratigraphy. This is our interpretation of the well. Now we have the maximum flooding surfaces from the 222 and then the 223. And so here's the correlation into the Davy Jones. So this is, we thought there was a fault here at the point, and then the salt well, and then another fault, and then this we thought was the Reclaw coming in here, and then the upper Wilcox and the lower Wilcox, and then down here to the Midway. And that line right there is the top of the Cretaceous, which the well never hit. Okay? So now Macarand came along in one of their internet places, and they made an interpretation of the Davy Jones for us. They felt they penetrated 8 gas sands with 200 feet of 200 net feet of pay in Wilcox sediments, and that includes the 1A, which is the Eocene portion of the Wilcox, and then 1B, number 2. These are different units that were formed by Zara from Chevron, and then they felt it went down into the Midway, and the temperatures recorded at the bottom of the well were about 400 degrees, and the well TD'd at 29,900. So this is the This is the Macarand's interpretation, which follows along real well with our interpretation. And so we start out here with the Wilcox, here at the top of Wilcox, This is the Paleocene portion of the Wilcox. So those units that I showed you, this is the, I believe this is the 1A, 1B, I mean, and then this is a 2, and this is a 3. But these are all the gas sands that they were recognized in the discovery well, which is the Davy Jones number 1. We'll come back to the next one later. And that looks like this on seismic. So here we have the Oligocene, here's the top of the Eocene, here's a nice salt well over here going all the way over. And this is the Davy Jones number 1. So this is the discovery well. So here it goes into the Wilcox, and these are the Wilcox sands that they have identified, and then it goes down into the Wilcox, but it doesn't, and it goes into the Midway, but it doesn't go into the Cretaceous. Okay, so now we'll go look at this Davy Jones number 2, which is right here, and I didn't have seismic for that. It wasn't out yet, but this gives you a little idea. Here's the Davy Jones 1, the Davy Jones 2, and this is the Macarand again, showing what's going on in the wells. So here's the discovery well, the 1, this is the 2. You notice they go through the Miocene and middle Miocene, and I think this is a little older interpretation, but they've got this nice salt well in here, and they go through the Oligocene, and they go through the Eocene, and then down here into the Cretaceous. We'll look at that a little more closely, and you'll see that, you'll see here that the...
Walt, can you project a little more?
Pardon? Oh, sorry. Oh, I forgot, sorry. Okay, so this is Davy Jones number 1, and this is Davy Jones number 2. So the Davy Jones, this is a correlation. Here's the Wilcox, top of the Wilcox. Here's the top of the Paleocene Wilcox, and you'll see that the number of sands, they have wonderful sands here and here, and then this is the top of the Midway. Okay, and then this, moving on steeper, we get this is top of the Cretaceous here. So as you move down into Cretaceous, they have about 500 feet of Cretaceous, and then they have about 400 feet of Tuscaloosa sands at by 29,000 feet. And after that, then they call these lower Cretaceous carbonates, and they even have here's some shows in the carbonates and also in the Tuscaloosa. And okay, and these are the units that we were talking about that they penetrated in the Davy Jones number 2. The first one was they had 200 feet of net pay. In this one, they have 120 feet of net pay in Wilcox sediments. And these are the units 1A, 1B, 2, 3. 4 may or may not have been recognized. And finally down here into the Midway. And now in the Davy Jones number 2, we go into some of the Cretaceous aspects. And we have, they penetrated, as I said, 550 feet of upper Cretaceous, and then 400 feet of my interpretation of Sedimanian Tuscaloosa sands at 29,000 feet. We've worked wells in the Tuscaloosa, and the sands in the Tuscaloosa are Sedimanian. And so I'm kind of assuming that this Tuscaloosa is the same age. This one has, these have 20% porosity, gas shows, and then again followed by 500 feet of actually Albion and Aptian carbonates at 29,400 feet. So we're talking about a pretty deep wells here. On seismic, again, this is the number 1 over here. Let's see that. appraisal. This is number 1, this is number 2. And again, you can see the real nice correlation they have over here. Here's the top of the Wilcox, and here's the Wilcox Sands, Wilcox Sands. Here they get down into the Tuscaloosa's right here above this limestone. But see how nice that limestone goes all the way across, but they didn't hit it there. Okay, now we'll take a look at the Davy Jones, and we'll kind of run over it a little further, and we'll look at the shell number 2 Baja, and the Unocal number 1 Trident well in Alamitos Canyon. So here's the Baja in Alamitos Canyon, and here's the Great White and all these other nice big wells. But this is the Baja, and here's the Trident right here. So this is a Trident. Trident was drilled by Unocal, and in the 557 Baja, we have 8 maximum flooding surfaces we could recognize. In the Middle Eocene Brecklaw, Paleocene Wilcox, and Lower Paleocene Midway formations. And we also recognized 6 maximum flooding surfaces in the lower part of the well, in the lower Cretaceous, in the Campanian, and possibly goes to Potterivian. And some of those ages came from Dr. Den from Marathon. Okay, so this is the Baja. And again, we had, I think, about 8 maximum flooding surfaces we recognized here in the, all the way from Middle Eocene, Lower Eocene, and into the Paleocene. And then we looked and found that when we first interpreted this well, we didn't know that these were Chicxulub sediments. And because we did find a few fossils in here. But since then, Dr. Richard Den has corroborated this all with the Gulf of Mexico, these Chicxulub sediments here in the Cretaceous. And these are the maximum flooding surfaces we recognized all the way from Campanian down here into the lower Cretaceous, which is in the Albian and Aptian, and hopefully in the Potterivian. There's a major unconformity at the top of the base of the midway top of the Cretaceous, and the ages are over here. I think this is like 49, and this is like 56. So there's about a 6 million year drop, 6 million year unconformity at this level. Another major unconformity is at the base of the midway, and the Cretaceous Campanian top. Did I make a mistake there? I think I did. Anyway, all right, so this is the lower part of the Baja. This is from Richard Ben, and this is the Paleocene. And here at the top of I put a maximum flooding surface on top of these Chicxulub sediments. So we call this the top of the Cretaceous. Maastrichtian's all missing, or this may be Maastrichtian. Anyway, this is about 600 feet of sediments. These are meters. There's about 600 feet of sediments assigned to the Chicxulub deposit. And then we have other maximum flooding surface here in the Campanian, Santonian, and Sedimanian and Albion. We're not able to recognize both in here, and we didn't have any fossils in there. And that the Chicxulub sediments look like this on a well log. So this is our first interpretation before we realized they were Chicxulub sediments. Going to go over into the seismic then for the maximum flooding surfaces. Here's the rec law, here's that boundary, 49 to 56, so you got this nice great big unconformity in this well. And then these are the various maximum flooding surfaces, and this is all in the Wilcox, all the way down to here, which is, now here you get to the top of the Cretaceous, and these are the Chicxulub sediments here. So these are this is the top of the Cretaceous, and this interval probably right about here is where the Chicxulub sediments are. And then below that we go in, it actually goes down deeper than I have it projected on here. Okay, then if you take the Wilcox and run to the east, this is the Baja, so using that as a guide, you're running all the way over here. It's the lower tertiary Wilcox. You can see it eventually fades out over here. And according to this slide here, we have maybe Jurassic sediments below. And this is another seismic line showing that. And again, here's the Chicxulub sediments right here below the Wilcox. And now we'll take a look and see what the 57 and the Trident look like. Actually, in both wells, we're able to find all these units of the Wilcox in both the Trident and the 557. And in the Trident, we have a series of maximum flooding surfaces running from the middle Eocene all the way down to the lower Paleocene. And it has a little bit of sediments here, which we found some Cretaceous fossils in, so we called it Maastrichtian. So this is a seismic line that runs all the way from the Trident, and we drilled 3 wells. The number 1 well has three reservoirs in it, and that correlates all the way across. This is the Wilcox correlating all the way across over here to the Baja. So this is the Baja, and it runs down here into the Cretaceous. And this one may have just gotten into the Cretaceous. 4,000 meters. So this is the summary. So here we go. So here's the bomb, the shell 557, Unicel 903, Davy Jones number 2, Davy Jones number 1, and this is the El Paso 223. I left off the 222. So here we are, we start off here, and in the bomb, as you can see, we had 21 maximum flooding surfaces. So we used this as a standard of reference because we had the seismic and we had the logs, and so we could, and the fossils, so we could do this, and then we correlated that. We can make this correlation. These are the maximum flooding surfaces that we recognized. So in the late Miocene and the middle Miocene and the early Miocene, you can see we have the same maximum flooding surfaces in the Balm, and we have that in the Davy Jones. It actually goes up. We don't have them up here, but you can correlate them over to that. So this is the nice correlation that you can do based on maximum flooding surfaces. Now, these are blank, but a lot of the blanks are because we don't have any sediments, we don't have any fossils, and we have no samples, so we don't have any fossils in there. So it doesn't mean that this is missing, it just means that we don't have any information on that. Coming down here into the Oligocene, the Aquitanian and the Chattian here, This is we find this in the balm, and the same Oligocene in the Unocal 903. The X's mean that we found the top of the Oligocene in these wells, but we don't have any maximum flooding surfaces that we can recognize. But we can find the tops of the units, but we couldn't, the resolution, we couldn't get into making maximum flooding surfaces. So here's the Middle Eocene, Middle Oligocene, big drop, and then we move into the Eocene, Middle Eocene, Lower Eocene, Paleocene. So we're getting here into the top of the reclaw. So you can see we're using these again, very datable, lots of fossils, and here in the shell, the 57, we can find a few maximum flooding surfaces. In the 903, we found about 8 or 9 of these that we could correlate back into the balm. And the top of the Oligocene, these are tops of these, like the top of the Oligocene, these are tops of the Middle and Eocene, Middle Eocene, and this is Lower Eocene, and down into the reclaw. So we could recognize those in the wells, but we don't get it down into the maximum flooding surface level of refinement. So now we're down into the Cretaceous, and I put this Eocene so you have an idea of where we are. So here's the top of the reclaw, here's the top of the Wilcox. So here's the Wilcox Paleocene, Wilcox, all down here, all the way down to the Midway's lower Paleocene. So here we have in the shell 57, 557, we have the nice Wilcox maximum flooding surfaces we can recognize, and we can recognize a few of those in the 903. And actually the sediments are here for the balm, but all we could do is possibly maybe make this as being Paleocene and this is Cretaceous. So in between there are sediments. If they're Wilcox, that would be great. So here Wilcox, before it's more Wilcox, and in the Davy Jones #1, we found these units in here, and actually we found the same in the Davy Jones #2. Going down a little deeper, top of the Upper Cretaceous, and again, this is the top of the Upper Cretaceous that we were able to recognize in the balm, in the Unocal 903, and in the Davy Jones #2, but not in the #1. And then this is the maximum flooding surfaces we placed at the top of these Chicxulub sediments in the shell #1. We didn't find them in the other wells. And then we go in from the shell, we go into, my light just went out. And anyway, you can see the top of the Chicxulub, and then we go down into the top of the Cretaceous, and then the 557. We recognized identified with the fossils that this is Lower Cretaceous and Albian and Aptian and Permian and Horaribian. So it gets pretty old sediments in that 557 well. And we found the Cretaceous in that Davy Jones #2. So we found Upper Cretaceous and Lower Cretaceous, Aptian, Albian in that well, but we didn't find anything older. And the only well that we found anything in, any older, was the balm, and that was Jurassic. So, okay, maybe just a few obvious conclusions that maximum flooding surfaces are very valuable surfaces for correlation in the Gulf of Mexico. We can identify those from all the way from South Marsh Island to all the way to the Bay of Campeche. And the reservoir rocks of the same age can be correlated using maximum flooding surfaces. Unconformities can be identified and the amount of time missing determined based on age datable maximum flooding surfaces. Thank you. Yes.
Yeah, I'm curious about the Chicxulub. Do you see the iridium layer, or do you see ash layers in the Chicxulub, or do you see disturbed fauna? Are they all disturbed because of the impact?
Richard Den is the guy who's really done a lot of work on that, and he's recognized that deposit in something like 25 wells in the Gulf of Mexico. He recognized about 25 of these in the Gulf of Mexico and in various wells. But he reported mixed Maastrichtian and Campanian nanofossils in these Chicxulub sediments. And we found a few forams in the same sediments. So, and he was able to correlate these Chicxulub sediments to these other wells based on calcareous nanofossils.
So something lived through the impact.
It either that or was turning up and lying down. The field here, oops, sorry.
So those are the sediments, basically, you know, when, yeah, I work with Richard Macarand. So 600 feet is unimaginable. So
I know.
they fill all the holes. So I think they were recycled from the and part of the big
a lot of it, and there's a lot of carbonate, very fine carbonate, and but a lot of other stuff in there with it.
But I doubt they have individual later. They sort of time datum, but there's a whole bulk of sediments.
No, it's just all mixed up.
Yeah, it's a 600 feet. I mean,
Yeah.
you're talking much precise layers here.
200 meters. Yeah.
Wow.
I believe it's visible on the Brazos River in the banks, if you go upstream in a boat, that you can see the Chicxulub layer, tsunami layer, and it's about 3 feet.
Really? And the Brazos?
Yeah, I believe it's the Brazos,
I haven't seen.
but it's only, you can only get to it by boat.
Oh, okay. Well, during the last Memorial Day, we could have gone there.
Good point.
We went to a house over in Ireland, and the lady said that at 4 o'clock in the morning, he knocked on the door and opened the door, and the boat was sitting with 8 people in it. And the whole thing was nothing but a light from the overflow of the volume. So maybe that's a little bit of the area. Anyone else? Yes.
There's another really important Macarand well, it's the Generette number 1. It was drilled not too long ago in northern St. Martin Parish. They took a conventional core in the Cretaceous section. And the word is they've got some outer neritic zone 3 paleo, which puts, but that well is positioned pretty far south of the established Cretaceous shelf edge boundary. So I'm pretty paleo brain light, and I'm kind of generally curious because there's a controversy of some people want to believe that those are redeposited bugs, that they're not in situ. What's the practices to know the difference between the two?
Well, if it's reworked, then it'll be out of stratigraphic order as you go down in the core. You can take the core every inch if you want and look at the fossil, and if you get things out of whack, some things are higher than others, and you need a stratigraphic continuous section. You can have things that are younger in the older, but you can't have the older in the younger. And if you do, that's when it's mixed up. So there's been a lot of problems here years ago in the Gulf of Mexico when you get the shallow water benthic forams coming down the slope and doing Lowstand and then all of a sudden you find that some people are calling this basin floor fan, and right above the basin floor fan you have these benthic forams that are interneritic or middle neritic, and then you want to call this some sort of delta or delta bar or something like that, and it's really a basin floor fan deposited in 4,000 feet of water. So, but that's not uncommon, should we say, so you have to do very detailed checklisting. You have to do the checklisting when you see that order, like I showed you, where first occurrence downhole, you see the first occurrence downhole. And the other thing is when you see that first occurrence downhole, and then all of a sudden you get a platform, and then that platform, and then you start going down again. That platform probably means it's an unconformity, because there's some time missing, because otherwise they would be going straight down consecutively, getting older. Anybody else?
Any other questions?
Yes.
I assume you looked at the frequency between these maximum flooding surfaces and condensed sections in terms of geological time.
Yes.
I mean, you've got something like 25 different maximum flooding surfaces over maybe a 50, 60 million year period. You're saying about 2 million years in between, but I assume the deeper section, you're really not seeing all the maximum flooding surfaces
No.
like you might in the Pleistocene through the tertiary. What's the frequency there in terms of?
Well, the problem with the problem when you get into the deep water is that the seismic is not good enough so that you can pick out the maximum flooding surfaces consecutively. You're going to miss some, because some of those, like the triangles I showed, some of those triangles are not very big. In other words, they are not extensive, so consequently you probably won't be able to see it too well. So we usually go through, you look at one of Gradstein or one of Old Bill's charts, you'll see that there's the lines of the maximum flooding surfaces have different intensity. So they have very fine ones, then they have a medium one, and then they have a big one. And if it's a big black line, that's a big flooding event, and you'll find that almost any place.
And those are third order?
Third order. And that's what we normally do. We get out the chart and we start looking for the big ones.
So
we call the big
what's the
flooders.
frequency? What's the frequency there? What's the?
Well, I'm not sure. It could be every million years, 2 million years. Where you get the big ones, probably not that, probably every 5 million years for the big ones, if you wanted to do that. But normally the third order are, like 2 million years or so for third order sequences, maximum flooding surfaces. So as you get up higher in the section, and younger in the section, they become more frequent. Just because there's a lot more sediment. You recognize them.
Any more questions? Okay, well, Walter, we have a speaker award for you from the HGS.
Oh, Texas.
Yeah. You take this off. That's just to keep it together. Okay, the meeting is adjourned. Thank you very much for attending.